Alright, welcome to the last segment of this exact equations conversation we're having. So, okay, let's say this. We started an exam setting, right? You're given a question, you looked at the question, you tried to answer from the separable point of view, no go. Then you go to linear, you see that this is not linear. Then you check whether this is an exact equation and you see it's not exact. So what are you going to do? So just before I answer that question, I want to say that we're still missing a fundamental understanding of the next topic, which is the substitution. But I assume that that's also not going to give you the answer that you're looking for, right? So what am I going to do? Well, do you remember that in the last set of segments where we have the linear equations, and this was the case, right, f of x, and this was not a linear equation. So what I did was I multiplied both sides of this equation by an integrating or integration factor, and the integration factor was p of x dx. Remember that, right? Okay, so now I will do the same approach over here. Unfortunately, it will be a little bit more dense. Just want to warn you, okay? So I can make a non-exact equation. I checked it and it's not exact, right? So I can make it an exact by multiplying by a particular integration or integrating factor. However, there is a loophole. We have to be careful about something. And let's say that this is the integrating factor, okay? There are two of them actually. I'll write two of them, then I'll talk, okay? Integral of m sub y, I'll talk about what m sub y is, minus n sub x by n dx. Okay, m, y will del m del y, and x will be partial of n with respect to x, as you can imagine, right? So obviously m is given to me in the question, right? So m is n times dx, remember that? N times dy. So these are given to me in the question itself. So I simply go ahead and take the partial of this with respect to y, and then minus a partial of this n with respect to x divided by n is given in the question. This will be an integration factor, but there's a loophole, like I said. This must be a function of x only. Okay, so this needs to be a function of x only. If it is not, it's not going to work. Okay, you can try it, it's not going to work. You will see that you're not going to get an exact equation, right? But also I have another one over here. This is one. I can have a similar one like that. So the integration factor of y will be e to the power of nx, same thing as above, except you see that the order is switched, divided by m dy. So I have a question. I said up here that it must be a function of x only. What do you think this needs to be? Must be a function of y only. Function of y, important, only. Okay, so do I really have to write these two actually? No, not really. You should be able to understand that this should be only a function of x. How do I know that? See? This integrating factor is only a function of x. Same thing over here, it's a function of y, as a reminder to you. So why don't we go ahead and solve a question to illustrate these fundamentals, okay? See whether this makes sense or not. Here's what the question states. 2y squared plus 3x dx plus 2xy dy will be equal to 0. Okay? So I'm going to go ahead and check whether this is exact or not to have an understanding whether, can I approach this from this angle. So I'm going to do del m del y. And obviously m is this, right? And n is this. So del m del y, the partial of the first term will be 4y. The second term doesn't have a y in it, so I'm good. How about del n del x? So looking at it, I'm going to get myself 2y, right? So you can see that this is not exact. Not exact. Then I need to multiply this by the integration factor, if possible. Okay, may not or may work. We'll find out. So the integrating factor, the one that should only be a function of x, let's go with it. My minus nx by n dx, right? By the way, did you realize that these are not additional work for you? You already get them when you're checking, if you're doing the proper analysis, okay? So you simply actually go ahead and insert this in here. So it's not too bad, okay? E to the power of, that's going to be 4y minus 2y divided by n. N is 2xy, right? Dx and you can see one more step, e to the power of, you can see the y's cancel, right? So I get myself integral of dx by x, right? So you can see this is obviously a function of x only. So this will work for me, okay? So what is this, by the way? So this is going to be e to the power of ln x. And what is e to the power of ln x? That is x. So now my integration factor turns out to be x. So let me go ahead and multiply the entire equation by x. So I'm going to get 2xy squared plus 3x squared dx plus 2x squared y dy is equal to 0. Why don't I go ahead and check whether this is exact or not to see whether I was really successful in making this an exact equation. So this is m, this is n, so del m del y will be equal to, it's going to be 4xy, the second term doesn't have any y in it. How about del n del x? And you will see here that I will get myself 4xy2. Do you see that? Now this is exact. So basically, I will go ahead and solve this equation, right? And at the end of the day, the solution will be the same because I'm multiplying both sides of the equation by x. Okay, so then I will, it's important to note that now I'm solving this equation, not the previous one, okay? I have to solve, you know, this and then that, all right? Not the m above, all right? And let's just write it over here. This is del f del x. This is del f del y. I'm going to start with the x direction, so I'm going to get myself f x comma y will be integral of x comma y dx. So if I insert that, I'm going to get myself 2xy squared plus 3x squared dx. So if I go one step further, I will get myself x squared y squared plus x cubed plus the integration constant is g of y. We talked about this many times. And again, I'm not done because I have myself an f, but I didn't really take advantage of the existing of this that I'm going to do now. So I'm going to pull my f from here and plug into that above equation. So the n, 2x squared y, will be equal to the partial of this one, x squared y squared plus x cubed plus g of y. And I need to take the partial of that with respect to y. So from here, then you're going to get yourself 2x squared y plus g prime of y. Obviously, g prime of y is equal to dgy dy. So you see these are the same. So you can see that I get myself a g prime of y is equal to 0, right? So from here, I get myself g of y is equal to a constant of c. So if I go ahead and write this, f x comma y will be equal to x squared y squared plus x cubed plus the integration constant of c. As this is a constant, we talked about this a few times. This is a constant. I'm going to combine those two, and I'll call you this. Plus x cubed is equal to a k. So this kind of does it for the exact equations sections. Okay. So the next one is going to be the substitution. It will also be a dense set of videos. I will be back with more videos for you. Okay. Have a nice day.